project titled Online Academic Course Performance Prediction Using Relational Graph Convolutional Neural Network. Online learning systems encounter the significant challenges, including the heightened dropout rate compared to the traditional education. Addressing these issues demands a robust framework for appraising the student performance and preventing the potential setbacks in the virtual education. A solution is of the deep learning online performance evaluation framework. It conceptualizes the relationship between the students and the courses as a knowledge graph, employing the advanced graph neural network to derive the student and the course embedding. Additionally, a recurrent neural network captures the temporal student behavioral data. This culminates in the prediction of the student performance in a specific course. The effectiveness of DOPE is suspended across the diverse scenarios pitted against the representative benchmarks too. And presenting a novel approach named the Deep Online Performance Evaluation that addresses the evaluation of the student achievement in the online learning environment along with the anticipation of the potential setback. With the using of LSTM as algorithm, DOPE's architecture involves conceptualizing the student-course interaction within the online system as a knowledge graph. By leveraging the advanced graph neural network, it extracts the essential embedding of both the students and the courses augmented by a recurrent neural network. The framework encodes the temporal behavior of the data within the system. This amalgamation culminates in accurate prediction of a student performance in the specific course. The efficacy of DOPE is underlined through the rigorous experimentation across the various scenarios, comparing its performance with the established baseline method across 6 distinct online courses. To deepen the comprehension, the framework undergoes an ablation feature analysis on the student behavior attributes. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the project, these are the steps we need to discuss. The first one is importing the packages. This step involves importing the necessary libraries and packages that will be used throughout this project of NumPy, Pandas, sklearn, Torch, Matplotlib, Seaborn, and of many more. And the next one is exploring the dataset. In this phase, the dataset is loaded and examined. Exploratory data analysis techniques are employed to gain the insight into the structure, size, and the characteristic of the dataset. This helps in understanding the nature of data and identifying the potential issues like of values, outliers, many more. And the third step is data processing. Data pre-processing involves cleaning and transforming the dataset to make it suitable for the analysis and the model building. It includes tasks like handling the missing data, dealing with the outliers, and transforming the feature if needed. And the next one is visualization using the Seaborn and the Matplotlib. Data visualization is done by using these two libraries to create a graphical representation that aid in understanding the pattern and the relationship within the data. And the next one is label encoding. Categorical variables need to be converted into the numerical format for the machine learning algorithms. Label encoding is one of the methods where the categorical labels are mapped to the integers. And the next one is feature selection. Feature selection involves identifying the most relevant features that contribute significantly to predict the power of the model. This step can help to improve the model efficiency and reduce the overfitting by focusing on the most important aspects of the data. And the next step is data splitting into the train and the test. The dataset is divided into the training and the testing subset. The training set is used to train the model, while the testing set is used to evaluate its performance. And the next one is building the model. This is the core of this project, containing of the various machine learning and the neural network models are constructed. The first one is Torch-based RGCM. This model involves utilizing a Torch-based implementation of relational graph convolutional neural network with the LSTM self-attention layer. RGCM focuses on capturing the relationship within the dataset by considering a graph-like structure. By incorporating the LSTM self-attention layers, the model can learn the temporal data dependency, making it especially relevant for the sequence like academic performance data. And the next one is LSTM plus CNN. The LSTM combined with the CNN is a hybrid architecture. It excels at sequence modeling and capturing the temporal pattern, while the CNN excel at the feature extraction through the convolutional operation. This combination is particularly beneficial for the time series data like academic performance, and it can capture the sequence dependencies in the student behavior. And the next one is random forest. It is an ensemble learning method that combines the multiple decision tree to make the prediction. It's particularly useful for its ability to handle the complex relationship and the interaction within the data. In the context of the project, random forest can capture the non-linear relationship between the various features and the academic performance. And the next step is decision tree. Decision tree is a tree-like structure where each internal node represents a feature and each leaf node represents an outcome. It's initiative and capable of modeling the complex decision-making process. In this project, decision tree can be employed to understand the hierarchy of features that contribute to the academic performance. And the next one is logistic regression. Logistic regression is a linear classification algorithm suitable for predicting the binary outcome. In this context, it be used to predict whether the student performance will fall into of the categories like of success or failure. Despite its simplicity compared to the other models, logistic regression still provide the valuable insight into the impact of individual features on the outcome. And the next one is SVM. It stands for Support Vector Mission. Is a versatile machine learning algorithm that performs both the classification and the regression tasks. It works by finding a hyperplane that best separates the data into the different classes. In this project, it be employed to create the decision boundary between the different performance categories. Its ability to handle the non-linear relationship and be enhanced through the kernel tree. And the next one is voting classifier. It combines the prediction of multiple individual models to make a final prediction. In this case, it mentioned of combining the multi-layer perceptron with the random forest and the decision tree. This ensemble approach leverages the strength of each individual model to arrive at a more robust and accurate prediction. The NLP can capture the complex pattern, RF can handle the diverse features, and DT can offer the straightforward decision tree. And the next point is user gives the input. Here we build a Flask as a web interface where the user can give the input to the application. And the next one is the given input is pre-processed for prediction. Similar to the data pre-processing step, this input provided by the user need to be cleaned and transformed into the format with the model to work. And the next one is trained model is used for prediction. The pre-processed input data is fed into the trained model, which then make the prediction based on the input feature. The model prediction include the various outcomes, whether the student will perform well or not. And the next one is, and the last one is, our final outcome is displayed. The model prediction is displayed to the user as of the final outcome with the help of the Flask as a web interface. And the execution of the project, to execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The data folder containing of the dataset that we used in this project, and the static folder containing of CSS, fonts, images, JavaScript files within it, and the template folder containing of the HTML documents. It typically include of home, index, results, sign-in, sign-up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is an SKB file which contains the information of algorithm and is loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in an individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to write the command cd space and paste this code folder path. By this, it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on enter button. Here it redirected to this page containing of some info and of the title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some input details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password. We need to fill those details and then click on the login button. Here it redirected to this index page containing of some input details like this. We need to enter those details to predict the performance of the person. And I am entering those details. Code module is of AAA and the code presentation is of 2013 J and the gender is of male and the region is of East Anglian region and the highest education is of HE qualification and IMDb band is of 90 to 100% and the age band is of 55 less than or equal to, and the number of previous attempts is of 0 and the studied credits is of 240 and the disability is of no. And then click on the submit button. Here it redirected to the result page, and viewing the result, the performance of student is withdrawn for online course based on the input given. And then click on the home button. Here it will redirect it to this page and we can re-enter the other details too. I'm entering of the code module as GGG. Code presentation is of 2014 J and the gender is of female and the region is of Yorkshire region and the highest education is of HE qualification and the IMDb band is of 50 to 60% and the age band is of 35 to 55 and the number of previous attempts is of 0 and the studied credits is of 30 and the disability is of no. And then click on the submit button. Here predicted to this page and viewing the performance of student is passed for online course based on the input given. In this way, we can predict the performance of the student using the relational graph convolutional neural network. And in conclusion, the proposed model for the course performance prediction called the Deep Online Performance Evaluation. This represents the online learning system as a knowledge graph and learns the student and course embodies from the historical data using the relational graph neural network. And also it utilizes an LSTM for harnessing the student behavior data into the condensed encoding. The proposed model is tested on the 6 courses from the older dataset, and the result shows the visibility of the dope in predicting at-risk students of ongoing courses. It investigates the usefulness of the different type of behavioral feature and observes that the dope encodes the data in an initiative manner.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.